Okay, we're back practicing on some new problems, and I got some advice that my videos should be more exciting and interesting, and I should go a little bit slower. So I may try to add some of that along the way. I think the people that had those comments maybe are just looking in the mirror and want a little more excitement, joy in their lives, and so they want to blame somebody else. You decide if that's you or not. These three questions are going to be the only ones we do today because they are going to take a little bit longer. So you've already tried to work them out. They're not as complicated as they look, but the format's definitely different than what you see in class probably. If x is greater than 3, which of the following is equivalent? Equivalent means the expression is the same to this. Okay, so what we have down here are some different factored versions. And so if you want to be able to compare, you need to change this form here. And those fractions right there are just begging to be added together. So you need to get a common denominator. And that would be using both of these values. So x plus 2 and x plus 3 is your common denominator. This fraction is missing the x plus 3, so we take x plus 3 times 1. And this fraction is missing the x plus 2, so to that we're going to take 1 times x plus 2, or just x plus 2. They made nice coefficients, you don't have to worry about that. So combine like terms, 2x plus 5 over x plus 2 times x plus 3. And it's all over 1, which means our final simplified answer is going to be the reciprocal, because we're dividing by a fraction, so you multiply by the reciprocal. So right away, you can see that the 2x plus 5, this is questionable right here because it's not a fraction. You might need to recognize that x squared plus 5x plus 6 also factors into x plus 2, x plus 3, which is what we found up here as well. So this one does not have a fraction either, but it does have that. We have common factors right there, so the correct answer is B. Again, this question, if you don't see how to do it, you might want to leave it, come back to it later on, see if you can figure out. You could guess and check by plugging numbers in and go that way, but it's a really slow method. Remember, we don't have calculators in this section. This one also a little bit tricky and bizarre. Exponential problem. If 3x minus y equals 12, what's the value of this? So we have this one equation. So all you can do with an exponential like this is try to change the form. So if I change the form, I want both bases to be the same. So 8 can be rewritten as 2 to the third. So I really have 2 to the third raised to the x, and I have 2 to the y. And so if you think about your rules of exponents, if you have x to the 7th over x to the 2nd, you subtract those powers and you get x to the 5th. Same thing is true here. This could be rewritten as 2 to the 3x minus y. And so when we look over here, conveniently, the 3x minus y equals 12. So if 2 to the 3x minus y, that's the same as 2 to the 12th, and that is your choice. If you're going to guess on this one, because I get the feeling this might be one that people guess on, you can look for some things like, oh, there's the 12 here, there's a power of 2 here, there was no power of 4 up there, there was a power of 8. If I were going to guess and I'd not work it out, A or D would probably be your best bet there. So here comes some excitement. There's a spider for you. Okay, exciting videos. The last one is also something you have done a lot in algebra, but not in this form. And so when in doubt, when they give you all these crazy variables, just multiply this out. Use your FOIL or your distributed property, however you were taught. So first terms multiply to give you abx squared. Outside 7ax, inside 2bx, and then the last is 14. And let's compare to what this is here. So we have 15x squared plus cx plus 14. So these are equivalent. So that 14 is out. It's not going to help us at all. So what we do have, though, is we have this AB equals 15. A times B equals 15. And we also know that A plus B equals 8. So it's a little bit, you can do this as a substitution problem and do some algebra, or you can say I need two numbers that add up to 8 that multiply to give you 15, kind of like the magic box things that we used to do with the diamond method for factoring. So, I mean, factors of 15, 15 and 1, 5 and 3. Well, 5 times 3 is 15, and 5 plus 3 is 8. But you have to remember you have two different possibilities. You could have A and B being switched. So the question says, find the values for C. So you go to the value here, and C is equal to 7A plus 2B. Same kind of equivalency there. So you got to plug in 5 for A. So 7 times 5 plus 2 times 3, and that's one of your answers. So 35 plus 6 is 41. And then you switch it around. 7 times 3 plus 2 times 5. So 21 plus 10, 31. So your correct answer is D. Those are some more difficult questions. Strategies I would use is expand anything you can expand. Try using properties. Get stuff into equivalent forms, and like this one, you get it to here, and you can kind of guess and figure it out. The problem is 3 and 5 is a choice, but if you don't read the question not asking you to find those two. That's all for this lesson. Thanks. Oh wait, there's your last bit of excitement.